Well, welcome back, guys. I mentioned in the video I just made um, that I will show you this. This is another small project. Um, what's happening is that I had in the last leaf shredder video that I have a screen, which I didn't have it at the time. Um, it wasn't working that well. It was, yeah, it was just the screen underneath and was piling up. There was no vibration, nothing. So, so I built something else. It's about 5 feet by 1.5 feet of like wooden frame and screen attached to it. And you just put it on some kind of incline and put the compost or semi-shredded leaves um, through it and then vibrate it, so the good stuff, that stuff that are small, screened out, well, big, screened out. So but I was having to shake it by hand. I put one scoop, shake it, and put the leftover big stuff back into one of the buckets and do it again. So I had this um, thing I had. This is basically a motor controller. What that does is, yeah, just speed control for, you know, huh. It was advertised as 12 to 24 volts, 30 amps. That's right, 30 amps. No way. And principle behind this is, yeah, power comes in and a protection diode and 5 volt. This is an operational amplifier. This is 555 timer, and these are, well, I put these two. There was actually one that was some weaker than these. Um, these are MOSFETs. Um, and that's the knob you turn, and it changes the value of the necessary components to set the duty, because this is doing pulse width modulation, on off on off. More time you're on, more power, more power goes to the motor, turns faster, whatever. More time, less time you're on, uh, duty cycle 50-50. For half of the time it's on, half the time is off. It's going to be half the speed. This is a cheap way of controlling motor speed. In the industry, things are, well, this controls the voltage, but the industrial stuff, they are the motors, they are torque, well, current control, which is quite a bit more complex than this and usually are much more expensive. So, and I can't remember what this operational amplifier did. Oh, yeah. I think. Let me see if I can. It's a comparator. Runs as a comparator, I think. Anyway, I forgot what. Something comes out. And what happens is you turn this knob clockwise, higher speed, counterclockwise, it goes off. But I wanted to, I make some changes. Some of the resistors too, and to make the frequency higher, um, down what I wanted. And this originally, I bought this, so this one had only one MOSFET. There's a crappier, like I said, crappier, ratings. So I put decent ones, two of them, so they would be sharing the load. and there was no flyback dial. I put a beefy one because motors are inductive loads, and if you do uh, shut a motor suddenly and there's a inductive spike in the opposite direction, uh, so across the motor leads. So anyway, that could be destructive. And inherently, MOSFETs have a built-in body diode because of the way um, the, they are made. Uh, but that's not always good enough, especially if you're switching loads, big loads or inductive loads of big inductive kind of loads. Then that spike could actually destroy this, which is what happened with the original one. I replaced these, and it's still happening. So this is not a good way of doing stuff. It's just not. If you have a small motor that, whatever, 16,000 RPM, this little thumb size motor, yeah, fine. But was running 24 volts, and the motor's pulling like 2 amps, so it's like 48 watts. Yeah, this is supposed to be doing what, 360 watts? It's all crap anyway. So I did away with this. I thought, I could get away with it. And what this did was I actually have kind of decent size, whatever, 36D size or whatever motor that I machine a little off-center, um, weight in there, just like a cell phone or whatever vibrator motor, but it's a little bit bigger. So I attached it to the side of the motor, the side of the screen. So, and the screen is on the incline, so as it vibrates, it's screens the big stuff out into the bottom bucket. This is separate from um, leaf shredder. But I take from the leaf shredder and put it onto this vibrating screen. This worked for a little bit until this crapped out, even though it's not, it's compared to nothing. It's pretty good. It was at the time for a little bit. Anyway, so this went out, and the body diodes, even though they are in parallel, sharing the load, these are out completely. Drain and source is short circuit. So yeah, you plug this in, it's on. Screaming, shaking violently in my case. So this is not really a good way of doing stuff. There's no overcurrent protection, there's no over voltage protection, there's no thermal protection. There's no protection. It's just not a good way to run inductive loads. So what can I do? Well, this is what I came up with. I didn't have to have this big capacitor in there, but I have some that I need to get rid of. So yeah, this is ground plus, and these goes to the motor. And guess what? That's a motor driver. It has everything in there. It has all the protection. It's within the voltage range that I need. And just like the other circuits, where is that? This is probably cheap. Well, I don't think it will be cheaper, but they had it at the time in the Chinese market, I guess. A bunch of these. That's the voltage regulator to run this, and then the comparator. Yeah. Okay, I think they use it as I don't remember. So uh, that's basically output of the timing. That pulse width modulation is uh, I guess buffered by this. And that's what it is, I think. So you don't directly connect that to there. So anyway, so similar thing. That's the voltage regulator, because this is not going to use that much, and this is getting the voltage. It's just not really. And I'm doing 12 volts, not 24 anymore, because I would have to change this. I have this on hand, 12 to 5 to run this and this, the input side of it, the logic side of it, but the motor side of it uses the capacitors, and then this is motor power, and this is the motor ground. I don't know why they staggered it, but this should have, well, I mean, maybe it spikes, whatever, but because this is rated to like 60 volts or something. Anyway, but it is a proper uh, motor controller. It has a pad underneath for heat dissipation. You may not be able to see it that well, but okay, let's see. Hide it. There we go. So I have 4 layers of exactly this shape. This is top layer, and there's one in the bottom layer. We'll get to these in a second. And a bunch of vias to help heat dissipation and decrease the resistance, or also the inductance of the trace. So proper motor controller, same circuit. I modified the other one to generate the timing, 555 timer with whatever. It's a little bit different. This one uses diode. Uh, anyway, but it's higher frequency, which is not that efficient, but it don't have to be. So, and there's some support, whatever the filter, capacitor, reservoir, and filter, and then this is the set, whatever, what you call it, current limit or something. Basically, this is valid to not limit the current, because the motor is not going to pull that much. And if short circuit for some reason, the motor, this is overcurrent protection. So this just is there just to be keeping things sane. So anyway, so what happens? Motor gets hot. Well, the motor controller gets hot. By the way, yeah, this feeds into the input of that. So as this goes high, low, high, low, high, low, this turns the motor depending on how much it's high versus low, the duty. And I set it to something frequency, and the duty, I don't care, as it's going to vibrate. I just ran off the top of my head. I think it's average is the 6 volts. The motor still turns pretty good and vibrates like hell, because I use a big, relatively big chunk of steel and Loctite it onto the shaft, and oh yeah, that thing is vibrating real good. Anyway, so let's look at the other stuff. What's in here? Well, let's do this. I removed the solder mask, and it's actually screen vibrator version 1, 2020 46 week. So we are in 50th or 49th. Are we? Yeah, we are in 51st. What? It's been 5 weeks. No, I don't think so. There's some more. Anyway, so the all 5 layers, 4 layers of this ground, which is connected to the pad underneath this to absorb the heat is passed through this exposed copper. Well, it looks like gold. Yeah, it's gold plated into this aluminum piece I machined. It's really tiny, 6 millimeters by come on, 6 millimeters by 6 millimeters by 10 millimeters or something. It's very tiny, and this is the 10 millimeter part anyway. So I used a tiny laptop screw, M2.5, and this is a very cheap copper plated aluminum heat sink that it was a little bit longer. I machined it and made this little bit, area that I would have conducted, well, thermally conducted epoxy just wraps around it. It's actually a little bit this way. So heat flows to here, flows to that, flows to this, and yeah, the amount of time I'm going to be running this, yeah, it's not going to matter. So yeah, I mean, it's that simple really when you're using a proper chip that is made for this purpose, not just turning on and off MOSFETs. It's just not, depends on application, but in this case, yeah, it's not, it wasn't good. I mean, I could have put a heat sink on that thing, behind this, and there is no, I would have to scrape. There's a pad here which also goes down, and this is 2-layer circuit, and I doubt it is 2-ounce copper, thicker copper. Normally boards are 1 ounce, so 1 ounce copper per square inch or something. Anyway, so I could have somehow attached what you call a heat sink to this thing. But the board itself is already huge. Yeah, this is exactly the same size of those that I have. I mean, if you look at the size, you can see that, this thing is going to be much smaller. Yeah, I mean, in fact, yeah, it is. Come on, measure. Oh yeah, sometimes it's just, yeah, it froze because I have something else open. Crap. Yeah, it's a 22 millimeters by 1 inch, 25.4 millimeters. Very tiny, just smaller than the heatsink itself. And I don't have to put any flyback diode, nothing. It's all in there, man. Yeah, there's the reason. But the fine people of Texas Instrument figure this stuff out, and I'll just pay for it. Well, like $2 or something, and few quantities. Yeah, but this will be on-off thing. You turn it on, it vibrates. There's no adjusting the speed or whatever intensity of vibration by regulating the speed, because I already did some, and if I really want to, I can just change the values of these and the capacitor too. I think yeah, I think I set it up to 16, 17 kilohertz. Just above, well, I don't hear much above 15 kilohertz. 16, I can barely hear it. But 17, yeah, 16.92 kilohertz or something it turned out to be. And I'm perfectly fine with that. So it's not going to make any motor noise, motor winding. Like, you put in 1 hertz or 4 hertz, like, as it's running, because that's the it's audible range. So, and I don't want to go above 20 kilohertz because it gets sufficient, I think. So yeah, that's it, man. I mean, this is sent and probably will be shipped tomorrow. It's already uh, been in fabrication. So I have everything else except for this, of course. So I ordered this along with some other resistors and capacitors I'm running out of. The whole thing was like $20. I got hundreds and hundreds of resistors and capacitors. Thinking when you do stuff electronics, unless it's something really high frequency or some specific purpose thing, it's usually not that cheap, not that expensive. So fixing things, it's not that bad unless you don't know what you're doing. You know, nobody teaches you this stuff. Nobody in school, no curriculum, unless you specifically take some projects to get familiar with things. They don't teach you how to make a motor control. Yeah, they teach 555 time because it's very common and fundamental, whatever. But no, like voltage regulator. Nobody. They have you use it in the labs and stuff, but you just see things and you know the background and you see things over and over again. It's like, oh, okay, they're using this. Oh, okay, they're using this again. And then things become familiar to you as soon as you look at it. Oh, okay, that's what they're doing. I wouldn't do it that way, but and this circuit can be done even with the same components as many different ways as there are people who can do it. So this is the way I do it. You may rightfully make it with a smaller capacitor, yeah, or whatever. So this will be coming and I will be showing it probably next weekend. So yeah, I mean, it's one thing after another. I always need something, so I always try to make something. And what I'm worried about, just wanted to share this. I got a lot of one-off things, and like for instance, I have a milling machine, and I made my own power feed instead of cranking the wheel on my own. I made one, but if it goes bad, yeah, I mean, there's no like I'm gonna have to be fixing, or I wouldn't sell it. I'm using it, but if I have to sell it, and whoever buys it, you know, if something goes wrong, they're gonna have to figure it out or get another one like $300, $400, a commercial one. Like I also made a broadcast spreader for the you know fertilizer and insecticides and pesticide, whatever, whenever I use them, granules. Yeah, I mean, the circuit in there is quite complex. I have two boards in there. One is the motor driver and all that stuff, and um, hefty motor driver, because I'm using a wheelchair, power chair, whatever they call it. The motors from that, it's a lot of power going to it, 24 volts. I thought the other day, I was like, man, if something happens to this thing, I'm gonna have to remake the whole thing. I forgot a lot of stuff. Like, I know where the program for it is, the processor and all that stuff. I'm using, I mean, the whole thing is I'm customizing everything, and it may be a problem at some point if I stop doing things the way that I used to do to make that, or the chips are not available anymore. It happened to me. Pressure sensor I was working with, I still have like three on hand. They phased that thing out. It's gone. And just, I was designing, it's available. I put everything on there. Like, I made a big uh, board. I actually did my own version of Wi-Fi thermostat because I don't like the quote unquote Wi-Fi thermostat being sold. It goes out from your network. It knows your credentials for your network Wi-Fi. It goes out to somewhere else. And when you want to turn whatever temperature up and down, your device talks to that server to tell it to send signal to your home. That's the dumbest thing in the Internet of Things. Is like, that is the dumbest thing. You think people, the basic decency, like information, the facts and whatever. People are not able to even handle that. It's just facts. People just mumble crap. I'm not talking about politics in general. Like, all kinds of disinformation out there. All kinds. It's so vulnerable. Like, how would you put something out, a dumbass little chip that has kind of Wi-Fi capability, goes and talks to somewhere? How would, like, security people, man, they would lost their crap. I just, yeah, like smart phrase. I don't care if I'm out of milk, man. Just because I want to know if I'm out of milk, I'm not gonna invite a bunch of hackers into my system. It's just stupid. And I'm afraid this is the point. I'm afraid that, there are a lot of non-technical people, and they take these things. Uh, they don't understand anything about it. They just take it on faith. Oh, Internet of Things, like Amazon, whatever, Echo or whatever, Alexa or whatever. That is just the dumbest thing you can do. Someone, something that is listening to you all the time. Have that in your house. Like, just don't have any windows and doors, nothing. Just save, really. Just unbelievable. And they're just listening to stuff. The integrity of the privacy is just unbelievable. And the problem I'm having is people will be group people um, don't understand the technology, but they're slaves to it. That's just what happens in some, of course, Hollywood. You know, things happen, everything goes back to Stone Age. What do? Right? Okay, no, nobody knows everything, but a lot of people knows nothing. A lot about the things that they use day to day. They look at that thing more than they look at their children. They have no idea how things are happening. And without those accessories, machines, they would be like fish out of water. That's just, I think it's dependent of being dependent on technology that much. Also, the point is making one-off things, and when things go bad or things phased out, you can no longer get. So anyway, that's kind of stuff I think about in my spare time, if I ever have. Yeah, just anyway, so yeah, that's a little rant ish. Yeah, that's yeah. Look for instance. Yeah, free version. It's 15. Now it's 21 is out. I think this has already been phased out. And what am I gonna do, right? Technologies keep going, and you always have to be informed and uh, researched about things that are happening, new technology. This the way that I'm, rendering this stuff, making them, using Eagle. How long is that gonna work? You know, so it's something. I think that's also another side point. People, like I start feeling. I'm not old, but you know how older people are viewed, like, yeah, technology illiterate, whatever, in the movies and comedy sketch and all that stuff. That's what they insinuate and sometimes flat out just say it. It's just they are they stop, you know, informing themselves, and that's where they left off. Like Twitter, older people they don't use because there were no freaking cell phones when they were your age or whatever. So that to them it's almost becomes like a barrier entry. You can't. It's too much of a hill for them to climb to get on. Like not all of them, but majority of them. So it's coming to a point. Like yeah, I'm really comfortable with this stuff. I'm doing what I'm doing, but how long will this be working? Something happens, crashes. Do I even have the installer for this 2015? No, well, actually, they went online. The free version now, it's online only, I think. So if something happens, my hard drive crashes, I have another desktop that has the same thing. But yeah, I mean, you can get the older versions, I believe. But I'm talking, as long as you understand the gist of what I'm trying to say. It's just that we just gotta keep up with the technology and way that things are being done. That's important. That's why doctors in this country, and maybe some others too, they have to take the board certified ones anyway. Why wouldn't you be one anyway? But yeah, they have to take the board exam every 10 years. You can't just, oh, I know that stuff and don't do any research, don't do this. And yeah, they require also, you know, for you to accrue some educational things, hours, uh, towards your whatever, you know, recertification and all that stuff. So that's kind of like forcing people's hand, even though they may not like to, but they kind of have to keep up to date. Same thing with the professional engineers, PEs, like really top of the food chain kind of stuff. Important, very important jobs. People who design bridges and such, you know, people who make vaccines or do heart surgery or whatever. They're gonna be up on their shit. If they're not, you may be dead, you know, collapsing bridge or bleeding brain. It's, yeah, but I don't know. For home stuff, I mean, I still got my notes from all the degrees I have, so I can technically go back and look at everything. But as the time goes, you kind of see patterns. You don't have to calculate everything. You know how things are done in a certain way, certain style, and then by looking at it, you think, oh, okay, well, it's gonna be like this, because you saw a bunch of math, you know, problems over and over again over the years, behavior is more of a second nature. Behavior of the system, you kind of like, oh, okay, well, that's going to oscillate, go away, and, you know, cause problems. Sometimes you forget, and then you look at it as like, oh, okay, and then you reinforce that. But that's the information you already know. But technology is a different thing. This sensor, this chip is here today. 10 years later, it's not. What are you going to use 10 years later? Right? If you stop learning and researching now, every day or every year, things will pile on, pile on, pile on. By the time it gets there, you know, you need to refresh. It's a bigger mountain to climb. And older you get, your cognitive, you know, brain cells, neurons, whatever, just like anything else, they don't work as good because they've been working so long. So I think that's what it is with being old. You just, it's too much of trouble to climb that mountain and whatever, do whatever people are doing right now in your profession or in social life. Yeah, well, to me, I don't care about most Twitter crap, you know. But yeah, some older people may do, you know, may want to send some stuff or whatever. And yeah, it's their problem, I guess. But you understand what I'm saying. Anyway, what the hell? Okay, this is what it is. And in the next video, and probably next this coming weekend, we'll have installed this, probably shred some stuff and then put it in here and demonstrate how it works. The other one actually briefly worked, so, but I didn't record anything. And this is what separates good and bad. Well, good, not my stuff, the chip. I didn't make the chip. So this is how you doing. This is professional. Yeah, you can get away with that, but why? I just had it laying around. Okay. I tried to make necessary changes and replace with the good ones and change the frequency so I wouldn't hear like as it's running. But at the end, time spent on this was waste. I should have done it with the proper way, using a proven technology. Oh well. Anyway, you guys have fun, and thanks for watching, and I will probably talk to you next week. Have a good weekend.